Okay, greetings everyone. Today we will continue on optimality. Okay, we will start to talk about this topic. This is really one of the important topics that we are going to. Of course, all the course notes, recorded events, you will find them on Moodle, and also you can find them on the recorded lectures. You will find them on the YouTube. So, anyhow, you can catch up with the contents easily, either from Moodle or from the recorded lectures. I want to speak with you today about optimization. We are living in an ongoing optimization problem all the time in our daily life. This is true. Whatever you do, you are searching for optimality. In anything that you can think of, it's all about optimality. It's all about optimizing what you want to do. So if you are searching for getting something, you need the best, the best thing that you can reach. You need the cheapest stuff you can buy with the highest quality. So everything you do, literally, it's all about optimization. Even in your decisions or anything that you would like to do, as going for a dinner or dating someone or trying to search for the next job or do anything, it's all about optimization. You are optimizing all day, everything, every second. We are in the quest of optimization. No one will need anything just to make things go. You will always looking for optimized options. This is why this topic is really very important in business, in engineering, in health, in whatever. Okay? Any decision we take depends on optimization, principles, and facts. This is why I usually look to the optimization issue as a life skill. It's not just only something to work with, it's a lifestyle. It's a lifestyle in everything. So whatever or whoever is very successful in maximizing what he needs, in minimizing what's gonna be lose or lost, he's gonna be successful in anyhow. Even in the photo, here you can see the man that's standing on the top of the mountain. Everyone searching for optimality. We will start these basic concepts by some tools. First of them is we will focus on the convex and the concave functions. Because once you go to optimization, you will need to analyze functions. So you are in between either an concave or convex functions. The convex ones will give you a minimum point. The concave will give you the maximum point if you are looking for this. So some of their useful properties in optimization concepts, it's very, very important for us. Then we will go into details of arguments, images, which is of our concern, and will be introduced on our optimization problems later, inshallah. Today I will focus with the concept of convex functions. How to know that your function is convex or it is a strictly convex function. In order to do so, the concept in a little bit in functions is given here, and it's stating that for any function f such that the domain into R, where D belongs to Rn, is a convex set, is said to be convex if for all xy belongs to this domain, and for all lambda is just only a constant that you can check or you can choose, and it is a value between 0 and 1. The following inequality holds. I can state that I can get an average between any 2 points in the domain, and the average or the weighted average is going to be lambda times x plus 1 minus lambda times 1. And then I will substitute by this value in the function. In order to have a strictly convex function, this value should be laid down or equal the weighted images of this 2 points that you make your weighted average. Okay? So it should be less than lambda times f of x plus 1 minus lambda times f of y. All of this is written, a function with a convex domain is strictly convex if and only f, the image of every weighted average, the image of every weighted, okay, pair of its arguments is lower than the weighted average, this is the weighted average, with the same coefficients of the images of those arguments. Once you start saying this, you feel it's complicated, but it's really very simple. Also, I can use lambda x plus 1 minus lambda y, or I would prefer to use the form as it is, as this one, or on this shape, which is 1 minus lambda a plus lambda b, and it's less than the same values. I know you are asking yourself about the value of lambda. Lambda is any fraction that belongs to the interval between 0 and 1, okay? But not the borders, yani not equal to 0 or not equal to 1, but within these 2 points. This condition for lambda will guarantee that if this inequality holds, that you have a strictly convex function, as we will see down the road. Let's test this on one example, but before so, I've taken the liberty to write to you the main steps. What to do if I want to discuss the convexity of a certain function. The steps is going to be very simple. First of all, I will pick 2 points, let's say P1 and P2. Since you are in R2, so y1 is going to be the function of x1, all right? So y is a function in x. So any point you will get to x1 and y1. y1 is f of x1. Same way for P2. Take any 2 points, x1 and x2, already you know the y's, form a weighted average of the points on the form 1 minus lambda x1 plus lambda x2. What's lambda? Any chosen constant between 0 and 1, but avoid the sides. So it may work 0.7, 0.5, 0.75, whatever, and we will go through this. Just bring these 2 points, this constant, apply in this value, you will find a number, then get the the value of the function corresponding to this value. So get the f value for the weighted average, then get what f of x1, f of x2, and then start substituting in this formula and then compare your results. If the value of the function at the weighted average of x1 and x2 is less than the weighted average of the images, it is strictly convex. I wrote it to them with respect to y, and also try to roll this for you using the f expression or the function expression to be easier for you for substitution and use. Okay, let us do this on one example, one of the famous examples, which is y equal to x squared. Girls, if you look to y equal x squared, you don't have to do further investigation. You already know that this is why we choose y equal to x squared, because it is really very simple curve. This is y equal to x squared, which means f of x is equal to x squared. So if I talk, and of course it is very obvious, it's a convex, okay? It's a convex curve, and you already know the crown of this point or of this graph. So all the geometric properties, you already know about them. Okay, let's see how the definition applies on this curve. First of all, let's test the convexity of x squared, which was well-known curve, at the interval of 1 and 3. So I will pick x1 and x2. Let's say this is x1 at 1, and for x2, which is at 3. Now I have 1 and 3. Now I will try to check or to choose the value of lambda. Let's choose value of lambda equal to 2.5. So if I choose lambda equal to 2.5. If you remember the check that we should do, it states that getting the function for 1 minus lambda of x1 plus lambda of an x2, which is supposed to be less than 1 minus lambda f of x1 plus a lambda for f of x2. This is what I'm going to check. So the first step is to choose x1, which is 1, x2, which is 3, then try to get the values of these functions, or the value of the function at these points. So simply, all I have to do is to just substitute. F at 1 is going to equal to 1. F at 3, so it's going to come up to 9. Now I have F1, I have F at 3. Then I will get the weighted average. Let's choose lambda for this problem equal 2.5, which belongs to the open interval 0 and 1. And then now let's form the weighted value or the weighted point, okay? So I will try to check. Then it's gonna be 0.5 times x1 plus 0.5 times x2. Dina, can you see why these two values are 0.5s? Because simply once you choose lambda equal to 0.5, if you try to substitute 1 minus 0.5, it's going to be 0.5. And also for the other value, it's going to be 0.5. This is why they are all the same for this problem. So it's going to be 0.5 times 1 plus a 0.5 times 3, which is going to come up to 0.5 times 1.5 plus 1.5, so it's going to come up to 2. Now I will need the value of the function at 2, so I will try to get f at 2. F at 2 of the function, the value for the function at 2 is actually the value at this weighted average between x1 and x2. All I have to do is to take 2 and substitute in the function, and it's gonna be a 4. So what we are trying to say is that for a point here weighted between 1 and 3, which is 2, if you find the value of the function at 2, you will find it equal to positive 4. Okay? Simply like, now, so I know at f at 2 or at x equal to 2, the value of the function is equal to 4. Now I will try to get these values, which is 1 minus lambda, f1 plus lambda of f2. I have f1, which is 1. I have f2, which is 3. So if I add 1 times 0.5 plus 9 times 0.5, all I have, what I'm going to have, I will have 0.5 plus 4.5, which is going to come up to 5, which means this side is equal to 5, which is greater than the value of this the value of this part, which is 4. And this, in this manner, the inequality holds, so it's correct. So this curve is strictly convex. اللي بيحصل دلوقتي برنسس دينا ان لو انا وصلت بين البوينتس دي اللي هي between 1 and 3 وجبت الفاليو بتاعت ال 5 الاقي 5 دي هنا. So it's completely true. The function, the value of the function at the weighted average is less than the value of the weighted images of this function. فعلا ده هنا ب 4 وده بكام؟ ب 5. Let's do it once more. دي الستبس many. اهو تاني once more, f of x equal x squared. This is the shape of our function. I will choose 2 points within this interval. Let's say 1 and 3. This is at 1 and that's at 3. I will get the corresponding values of these functions. Then I will try to check this inequality, which states y at lambda less than 1 minus lambda, y1 plus lambda, y2, where lambda is any value between 0 and 1. Okay, I will make the value of lambda equal to 0.5, and that's the midpoint between 0 and 1. Now we will start substituting. So getting x lambda, which is 0.5 times 1 plus 0.5 times 3, will lead to 2. The value of the function corresponding to 2 is going to be 2 to the power of 2, which is 4. So the value of f at 2 is equal to 4. If we try to get the weighted average for the images, it's going to be 1 minus lambda y1 plus lambda y2. That's going to be 0.5 times the value at y1, which is 1, plus 0.5 times the value at y2, which is 9. And this is going to come up to 5. If you try to compare these two results, you will find that the value at the weighted average is less than or equal the other or the right-hand side. So it holds and the inequality satisfied. The function is strictly convex by the idea. This is a mistake from me. I should write here strictly convex. Okay? Since the inequality sign is less than. If it is less than or equal, as we will see down the road, it will be different. In a similar manner, if you look in depth to what's happening, that's the part of the curve which contains a convex function. And this point is the point at the weighted average. And that's the point on the line segment connecting these 2 points. I've explained all of this, that the blue curve shows the function, the dashed gray curve actually is the chord line which we get it by interpolation between the x1 and x2. The green dot shows f of 1 minus lambda x1 plus lambda x2. That's the green point. And the red dot shows the value, okay, shows the value on the chord, which actually is the value 1 minus lambda f of x1 plus lambda f of x2, and it lies on the chord. This visual confirms that the convexity of the function curve stays as we spoke previously. If I'm talking about concave curves, if we want to talk about concave curves, you will find it's completely the converse of what we said. So you will find this inequality, f of 1 minus lambda x1 plus lambda x2 is greater than 1 minus lambda f of x1 plus lambda of x2. And this way, in this manner, it's going to be a concave. Concave is very important for us because it determines, down the road we will know, that's a concave curve, which is a maximization point. So if you are targeting maximizing your profit or maximizing your sales or whatever, or revenue, so you will be interested in the maximization functions. And if you are trying to minimize, also a part of minimization of optimization is to minimize your costs, for example, or your expenditures, or whatever, or your efforts, okay? Okay, so it's gonna be a convex. Here it is exactly as I told you. So the orange curve shows the function, and the line segment here, it's connecting just 2 points from these 2 points. If we try to evaluate j of 1 minus lambda x1 plus lambda x2, it's going to be the point on the concave curve. If we try to get the value of 1 minus lambda, g of x1 times 1 minus lambda plus lambda g of x1, it's going to be the point beneath the curve. So in this manner, this inequality, it's going to be, as I told you, the converse of the or the inverse of the previous inequality, and so you will have a concave curve. Okay, let's try another values or another interval instead of having 1 and 5. And let's also choose another values of lambda and see if it's gonna different on the same curve from a point to point or not. So if we once more consider f of x equal x squared, which is an example of a convex, strictly convex curve, and for the period a and 5, so this is x1 and that's x2. So once more, I will try to choose to check if this inequality holds or not. But in this time, I will be talking or dealing with 1 and 5 for this point and that point. Once more, I will try to check or to choose the value of lambda. Once more, lambda is a value between 0 and 1. Let's pick 0.5 because we changed already the value. The previous 2 points that we choose is 1 and 3. Now we will check at 1 and 5. And using and keeping lambda equal to 2.5. So once we go to 0.5, and we are talking about 1 and 5, the middle point or the weighted average, it's gonna be 1 minus 0.5 times 1 plus 0.5 times 5. Here we go. This is half times 1 plus a half, which is 0.5 times 5. Okay, so this is going to be 2.5 and this is going to be half. So the sum of both of them is going to be 3. So the value at 3 is going to be 9. Okay, so now I have the weighted average and I have the value of the function at the weighted average. Are you with me now? Okay, same way like, so that's the image which is equal to 9. I will try to get half of f1 plus half of f5. Okay, wait. 1 to the power of 2 is going to be 1. 5 to the power of 2 is going to be 25. So actually, I'm going to evaluate 1 times 0.5 plus 25 times 0.5. And this is what's going to happen at the time being. This is half times f1 plus a half times 25, which is going to come up to 13. And once more, the inequality holds. This is the point connecting the line segment. If you do a line segment between 5 and 1, you will find this point on this line segment. And also, once more, the inequality is satisfied. Because the value on the curve is just only 9, while the value of these two images is going to come up to 13. So once you start substituting, you will find what I'm telling you about. So it's complete. Once more, strictly convex. I'm sorry for this. I will try to adjust it. So it's strictly convex function. Right. Do you think it's going to make a difference if we change the value of lambda other than 0.5? Let's check. I will keep the interval as it is, which is 1 and 5. And then I will pick the value of lambda, which is 0.25. Also still a value between 0 and 1, but it's different than the value that we choose previously. Okay? So all I have to do now is to apply this weighted average. Here is 1 minus lambda, so it's going to be 1 minus 0.25, so it's going to come up to 0.75. And here is going to be lambda, which is 0.25. Okay, let's do this. So, if you choose lambda equal to 0.25, so it's going to be 1 minus 0.25, which is 3 over 4, 0.75, times 1, plus 0.25 times 5. Once you start adding them together, أول ما أجمع دول على بعض هيدي ده 3 over 4 و 5 over 4, which is gonna come up to 8 over 4, which is 2. Once you take 2 and substitute in f of x, which is x squared, so the value of this function is still equal to 4. Once more, 4 is on the curve. I will try to get the weight of the images. So I will need the image at 1 and I will need the image at 5. For 1, I will multiply by 0.75, and for the 25, I will multiply by 0.25. The value is still equal to 7, which means it is above this value. Here we go. That's the value of 7, which is above the value at 2. Which means also still the same meaning. That's if you have the line segment, you will find this value above this point, so there is no difference if you change the value of lambda. We have tried it, or we discussed this case when lambda equal to 0.5, and we also discuss it at lambda equal to 0.25. In a similar manner, for the same period, here we go. Of course, this is 5, as I told you, this is 4, and that's 7. So still the inequality holds for this function, and it is strictly convex. Okay, the last one, let's try to be 0.75. It's another thing. I will redo everything once more. Also keeping the interval to be 1 and 8 and 5. So, in the first trial, we started by 1 and 3. We discussed the case at 0.5. It's working very well and strictly convex. Then we changed the period to be from 1 to 5. And we chose 3 values of lambda. One of them 0.5, which also worked very good, strictly convex. And then we choose at lambda equal to 0.25. Now we are discussing the case of 0.75. And it's also will come really very nice and very good. This is the value of y, and this is the weighted value of the images. Once more, 1 times 0.25 plus 5 times 0.75, it's gonna come up to, لو أنا عملتهم هما الاثنين, دي a quarter, then this is gonna be 15 over 4, so it's gonna come up to 16 over 4, which is 4. 4 to the power of 2 is gonna be 16. يبقى أنا عارف إن عند القيمة بتاعت 4 الفاليو بتاعت الفانكشن بتاعتي ب 16. Once more, لو أنا try to see the case of once you start using the images, it's gonna be a quarter times f1 plus 0.75 times the value of the function at 5, which come up to 19, still above this point. As you can see, it's still above this point, which means that it is strictly convex function and the series. شهد انت معايا؟ انت معايا؟ طيب شوية. بصي الشكل اللي انا بتكلم عليه ده convex function صح؟ نازل اهو. لو انا خدت اي خط مستقيم كده اكيد البوينتس اللي موجوده عليه اعلى من البوينتس اللي موجوده فين؟ على الكيرف. اذا ده حصل يبقى الشكل اللي انت شايفه قدامك ده اسمه ايه؟ كونفكس. وهو ده اللي انا بحاول اثبته. ده الشكل الكونفكس. انا اخترت نقطتين، ادي نقطه ودي نقطه. النقطتين دول جبت حاجه in between them. اللي موجود in between them ده هيتحسب تبعا للويتد افريج اللي انا قلت لك عنه. اللي هو ان انا اضرب 1 ماينس لامدا x1 بلس لامدا 2 x2. ضربت 1 مين 1 ماينس لامدا؟ فراكشن يعني. بس عشان اظبطه ويبقى ده ويتد انا بختار لامدا واجيب الثاني الكومبلمنتري بتاعها 1 ماينس الفاليو. معايا جميل؟ يبقى انا قدرت احدد الفاليو. الفاليو دي هعمل فيها سبستيتيوشن في الفانكشن باي اتسلف. هيديني الفاليو بتاعت البوينت. يبقى انا كده جبت البوينت اللي موجوده على الكيرف. فاضل اجيب البوينت اللي موجوده على مين؟ على اللاين سيجمنت اللي كونكتنج التو بوينتس دول. طيب هجيب البوينت دي ازاي؟ هجيب الفاليو بتاعت الفانكشن عند x2 واجيب الفاليو بتاعت الفانكشن عند x1 وهضرب كل واحده فيهم في نفس الارقام اللي انا ضربتها في x1 و x2. ده اللي الانيكواليتي بتقوله. لازم لما اعمل كده يكون القيمه بتاعت النقط بتاعت الايمجز اللي هي واقعه على الخط المستقيم ده تكون اكتر من الكيرف اللي انا بكلمك عنه. اللي بيحقق الشغل ده كله الانيكواليتي اللي حضرتك بتشوفيها دلوقتي اللي هي الانيكواليتي. ده الفاليو بتاعت النقطه على الكيرف وده الويتد افريج او النسبه بين الارقام اللي انت اخترتيها. لازم ده يكون اقل من ده. اذا ده حصل يبقى ده على طول عندك strictly convex relation. طيب بص بقى انا استفدت ايه ان انا استخدمت 0.5 و0.25 و0.75 والانترفال 1 و 5. لقيت حاجه غريبه جدا. لقيت ان ده كان عند قيمه لامدا بتساوي 0.75 وده حصل لما انا استخدمت لامدا بتساوي كام؟ 0.5. حركوا معايا؟ تاني انا رجعت قلت انا عندي اف اوف اكس اكس سكوير. عملت فيها اكسبيرمنت ظريفه قوي لان انا ثبت قدامها مين اللي موجود؟ الانترفال اللي هي 1 و 5. واحنا اصلا في الشويه اللي فاتوا دول حلينا المساله دي كام مره يا برنس الشات؟ 3 مرات. مره عند 0.5 ومره عند 0.25 ومره عند كام؟ 0.75. لما عملنا كده كلهم بلا استثناء حققوا الانيكواليتي صح؟ وبالتالي لانهم بينتموا لنفس الكيرف which is strictly convex. لقيت كمان معلومه غريبه جدا ان الثري بوينتس دول بينتموا للستريت لاين اللي كونكتنج 1 ومين و5. يعني لو عملت خط مستقيم انبهر مش شايفك منبهر. لو وصلت النقطتين دول ببعض كده الاقي البوينتس دي موجوده عندي. بالفعل ده موجود عند لامدا بتساوي 0.75 ده موجود عند لامدا بتساوي 0.5 وادي لامدا بتساوي 0.25. يا شباب انتوا ازاي معايا وانتوا باصين في السيلفونز؟ يبقى ادي الثلاث بوينتس اللي انا بكلمكم عليهم. طبعا لو انا بصيت على اللاين سيجمنت اللي كونكتنج 1 و 5 الانترفال هلاقي الثلاث نقط واقعين فين؟ عليه على نفس الخط. على فكره المعلومه دي مش بس عند سبيشال انترفال، يعني مش عند انترفال واحده ده عند كل اي نقطتين انت تختارهم على الكيرف. بدليل اهو بيقول لك هنا all the points with a weighted average considering lambda is any value between 0 and 1 will be on the line segment connecting F1 and F5 in general. طيب لو انا غيرت خدت نيجاتيف 4 و2 يحصل نفس الكلام. طيب لو انا غيرت وخدت نيجاتيف 1 و3 ادي نيجاتيف 1 و3 اوكي برضه يحصل ستيل نفس الكلام. لو غيرتها وخليتها نيجاتيف 5 و4 ادي نيجاتيف 5 و4 برضه لو عملت هتلاقي نفس الكلام. يعني ايه لو عملت؟ يعني لو رحت جاي مثلا واخد لامدا 0.25 هضرب 0.75 في ماينس 5 و0.25 في 4 اخد القيمه بتاعتهم اعمل بيها سبستيتيوشن في الفانكشن اسيبها على جنب. بعدين اجيب قيمه الفاليو بتاعت الفانكشن عند نيجاتيف 5 اجيب الفاليو بتاعت الفانكشن عند 4 اعمل نفس الستبس دي. وهضرب الاولاني 0.75 وهضرب الثاني 0.25 برضه هلاقي النقطه بتاعتك موجوده اعلى الكيرف. Do you understand what I'm saying? So it's working for everything. So the comment on this, all the line segments that connects points on the graph of f, with the exception of the end points, بعيد عن end points اللي انت بتتكلم عليهم, are above the graph of f. That's f of x is strictly convex. The previous results can be proven analytically. يعني أنا ممكن أثبتها analytic. أنا هنا I've tried to prove it with you for multiple choices of lambda. We tried lambda equal 0.5, equal 0.75, equal 0.25 for one interval. Then we changed the intervals. If we did the same, it will be the same result. But it's not an analytic proof. If we want to do the analytic proof, it's simple. But I'm not going to go through it. It's very, very simple. You'll find it on the slides. This is the value using lambda, and that's the value of the functions. If we start substituting in x squared and just making a simplification, we will reach the inequality that proves or the proof of this property. Okay? فأنا مشيت بنفس الأسلوب بنفس الخطوات هوصل لنفس الريزلت. طيب في classification of convexity. بيعمل classification للfunctions based على الانيكواليتي اللي انا بتكلم عليها دي. لذلك المفهوم بتاع الانيكواليتي ده مهم قوي انك تبقى فاهمه. اوكي؟ واضح؟ تمام؟ اوكي. طيب امتى يبقى عندك strictly convex function؟ يبقى عندك strictly convex function خلي بالك لو انا عندي القيمه بتاعت الفانكشن عند الويتد افريج less than الايمجز او الويتد ايمجز. معايا يا شباب؟ less than. طيب وده الشكل ومعناه ايه الشكل اللي موجود؟ ده شكل شيء كونفكس. اوكي؟ ده كونفكس لو انت بتتكلم على اكس وواي، لكن هنا لو انا بتكلم ان 3 دي يعني اكس وواي وزي يبقى ده الشكل اللي انت ايه شايفه اكنه بارابولويد وانت بتتكلم على القاع بتاعه. اوكي؟ بصوا هنا لو انا وصلت straight line or line segment between any two points connecting any 2 points on the curve, you will find the points above the curve by itself. يعني معناه ان الانيكواليتي بتاعتك دي اهو. All the images of the weighted average are lower than the weighted average of the images. Or graphically, if all the line segments connecting the points on the graph are above the graph. I wrote it for you because maybe you will have a multiple choice and he will ask you in mass word expressions to determine or to choose which one is the correct answer. Do you read me? Okay, very good. طيب, what happened? This is less than. What's gonna be the case if you have less than or equal? If for some points the inequality is less than and for other points on the curve, okay, you will find that these two guys or two sides equal to each other. إيه اللي يحصل؟ يعني مش less than happened إنها at certain point أو at certain value it is less than or equal مش إيه اللي يفرق؟ اللي يفرق في الحالة دي إن ده الشيب يدينا. بصي لو أنا بصيت على الشيب بالشكل ده ألاحظ إن الستريت لاين ده أو اللاين سيجمنت ده هو فعلا البوينتس اللي عليه above the graph. But maybe you will have line segments or points on the graph by itself. In this case, you will have a convex but not strictly convex shape. طبعا موجود عندك هنا انا برضو كتبته all the images of the weighted averages are lower than or equal, okay, to the weighted average of the images or graphically of all the line segments connects points on the graph or are above at the same level of the graph. طبعا في هنا نقطة لازم تخلي بالك منها إن كل ال strictly convex functions هي already convex functions بس ال converse of this statement is not true. العكس بتاعه مش مظبوط. اوكي؟ طيب اعرف منين ان انت عندك كونكيف؟ بدل ما انت كنت بتتكلم في لسان ايه اللي هيحصل يا شباب؟ العلامه تبقى ايه؟ greater than. وده يبقى الشكل لو انا بعمل كده، لو انا عامل كده، يعني لو الشكل بتاعي لو انا كونكيف يعني كده. حابب الشكل ده؟ يبقى في الحاله دي كل البوينتس اللي موجوده على الكيرف هي اللي هتبقى above اللاين سيجمنت اللي كونكتنج التو بوينتس اللي احنا بنتكلم عليه، وبالتالي الانيكواليتي بتاعتك ايه اللي هيحصل لها؟ هتنعكس. اهو ده الكلام بالظبط. This is 1 minus lambda A lambda B is greater than y minus lambda f of A زائد lambda f of B. بص ده كأنه طاير فوق وكل اللاين سيجمنتس البوينتس اللي موجوده عليها are lower than the graph، اقل من الجراف. طبعا inequality was inverted we will have a condition for a concave curve ونفس الستيتمنت اللي فات انا كتبته لك برضو just in case انه يبقى موجود معاك. In a similar manner if it is greater than or equal neither or instead of having strictly concave you will have concave function as you can see. طيب if one of the points يعني at the majority of the points let's say the majority of the points approve the first inequality and just only one of them didn't approve this one inequality or took the other inequality يبقى ده معناها انها not cave not convex function. يعني function بتاعتك لا هي concave ولا مين ولا convex. Are you with me؟ وin this غالبا